All right. This is similar to the last chapter 2 problem where we're just kind of using some basic trig and our knowledge of triangles and then finding the average normal strain. All right, so the problem is the pin-connected rigid rods AB and BC are inclined at angle or at theta 30 degrees when they are unloaded. Then when the force P is applied, theta becomes 30.2 degrees. Determine the average normal strain in wire AC. All right, so what do we know? Say theta initial is equal to 30 degrees, and then theta final is equal to 30.2 degrees. And they want us to find the normal strain of this, not the rigid rods, but of that little cable at the bottom connecting the two pins. All right, and this equation be equal to that difference in elongation over the original length. So we need to find both of those parts of this equation. So let's start with the bottom. That original, just do LAC. So you could go through do some trig, or we can notice that these two thetas summed together are actually equal to 60 degrees, meaning all of these angles are 60 degrees. Sorry, that got messy, but so that makes it an equilateral triangle, meaning that when it's unloaded, all sides of this triangle are equal to 600 millimeters. So that was quick. Just using our nice knowledge of triangles. Next, we need to calculate, remember this part, this elongation of AC will be equal to, we'll call it AC prime minus that original length that we got right here, that's 600 millimeters. All right, so let's find this LAC prime, the stretched length after we apply our load. All right, so, and this will be equal to 2 times the stretched length of BC times sine theta. Just to break that down for you, if you're having issues understanding what is happening with that equation, we're just kind of splitting that triangle. This side right here, that's our 600, or actually, let's keep it simple. This is that LBC, that's that length. This is our angle theta. And right here, this is half of LAC, of that length of AC. So we just are rearranging using, sine, get this, go over here, get our equation, and it tells us that these are rigid rods, so the length of BC will still actually just be 600 millimeters. This equation. And now we'll use our new theta, which is 30.2. Solve that. We get that our new length of our cable AC is equal to 603.6239 millimeters. That's our new length. Go ahead and plug that back up here, getting our average normal strain for that cable. Just write it all out. Then divide by the original length. We get 0.00604 millimeters, which seems fitting. It's very small change in length, but alright. Oh, and unitless, sorry. Didn't mean to confuse you.